Alright, problem 5a, another really cool problem that I like using sequences and series. We want to find the infinite sum of this series 6 over 9 squared, n squared minus 1. But we have a problem. This is not geometric. This is not arithmetic. So how do we find this value? Well, you might start listing terms and see if that gets you anywhere. 6 over, notice we're starting at n equals 2, so our first term we're going to take 2 squared is 4, minus 1 is 3, plus our second term, 6 over, now second term, weird, now we're talking about n is 3, so 3 squared is 9, minus 1 is 8, plus our third term, 6 over, now we're at n equals 4, 4 squared is 16, minus 1 is 15. I'm not noticing a pattern. I'm not going to be able to figure out how to add all this up. It looks stinky poopy, so I don't know what I need to do. Oh wait, maybe if we rewrite this fraction as a sum of two fractions, maybe some cool stuff will happen. And oh, that's right, they did say in the problem, find the sum of the telescoping series. That's what they mean by telescoping series. That's when you rewrite a partial sum and magic happens and terms cancel out and you're able to see what the sum is. It's really, really cool. So let's do that. Let's rewrite this this general term 6 over n squared minus 1 as a sum of two fractions. So let's use partial fraction decomposition to rewrite this. Remember, first step is always just going to be to factor that denominator. This n squared minus 1 is a difference of squares, so we're going to get n minus 1 times n plus 1. Cool. And now is when we actually split this up and say a over n minus 1 plus b over n plus 1. And now we want to multiply by our original denominator on both sides. If we do that, we're going to get 6 equals a times n plus 1 plus b times n minus 1. And if you don't know how I got that, go back and watch the video 1b. I explain that in greater detail, or go watch one of those partial fraction decomp videos that are on the video, not from this study guide, but from when I was gone. You guys can watch that. The link is on our website. Okay, let's keep going. Let's be clever about how we solve this and use our cover-up method to eliminate one of our terms. So if we substitute a negative 1 in for n, notice then that we get some simplification here. Negative 1 plus 1 is 0, so that whole term is going to go away. And we're left with 6 equals negative 1 minus 1 is negative 2, so we've got 6 equals negative 2b. Divide both sides by negative 2 to get negative 3 equals b. And let's do the same thing, except let's substitute in a positive 1 now. Do that, you're going to get 6 equals 2a, and our b term has been eliminated. And so we're going to get that a is 3. Okay, whole point of that was now that we have that, we can rewrite this as that partial fraction. We can substitute it back into how we have that written there. So we can write this as our value for a, which we found to be 3 over n minus 1, plus our value for b, which is negative 3. So I'm actually going to write that as minus 3 over n plus 1. Which again, you might be like, okay, cool, I still don't know how to find the sum of that series. And also I should be careful here. I should still write my sigma notation there that I have from the beginning. So I'm going to do that. Throw that guy right there, because that's really what we're dealing with here. We're still dealing with that infinite sum. So now let's start listing some terms and see if that gets us anywhere. I think it will this time. So again, notice we're starting with n equals 2. So substitute in n equals 2 into both of those fractions there. So we're going to get 3 over n is 2. 2 minus 1 is 1. Minus 3 over, again, n is 2. So 2 plus 1 is 3. Okay, that's our first term that is for a sub 1. Well, okay, I guess technically, okay, I'm going to write it as a sub 2 since we started with n equals 2. It doesn't really make a difference. It's our first term, but we're starting with an n value of 2. Okay, let's list the next one. So plus 3 over n minus 1 will increase the value of n. We just did 2, so now we need 3. 3 minus 1 is 2. So we get 3 halves. And then minus 3 over, again, n is 3 now. 3 plus 1 is 4, so we got minus 3/4. Let's keep going. So again, that's like, I'm going to write it like this. That was for n equals 3, and that first one was for n equals 2. Now we're going to list it for n equals 4. Hopefully we can start to see a pattern here. So plus 3 over n minus 1. 4 minus 1 is 3. Ooh, okay, finally, this one's taken a while. Minus 3 over 4 plus 1 is 5. So that's for n equals 4. And now we'll do it for n equals 5. 3 over 4 minus 3 over 6. So I'm going to scoot this page over to right there. Wow, that's not much room. Let's do one more just to like really, really set this home. We'll do n equals 6. So let's get 3 over 6 minus 1 is 5. Minus 3 over 6 plus 1 is 7. And then I'm going to do a plus ... there to say that this is going to keep going forever. But now let's find our pattern for what is going to cancel out, because that's what we're interested in. So notice we have a negative 1 and a positive 1, and those are going to cancel. And we have a positive 3/4 and a negative 3/4, and those are going to cancel. And we have a negative 3/5 and a positive 3/5, and those are going to cancel. So like if you think about it, look at like starting with this term, we had to go 1, 2, 3 terms down the row to find the one that's going to cancel with it. And for this term, negative 3/4, we had to go 1, 2, 3 terms down the line to find something that canceled with it. Negative 3/5, we had to go 1, 2, 3 terms down the line to find something to cancel with it. So negative 3/6, we're going to need to go 1, 2, 3 terms down the line to find the one that cancels with it. So I would put money that if you try to do n equals 7, 3 over 7 minus 1 is 6, and you see we will get our positive 3/6 there that it's going to cancel with. And this is going to keep on going forever. That negative 3/7 will go 3 terms down the line and cancel with something. But notice that 3 over 1 and that 3 halves never canceled with anything. And they never will. So that is going to be what our sum. Everything else is going to cancel, but this series telescopes down, compacts to just that sum right there. 3 plus 3 halves. So the sum is just 4 1/2. That's sweet.